Okay, we are starting chapter 5, and the first section is on taking the derivative of natural log functions. So before we start talking about the derivative, so I'm going to skip that first part for now, we're going to talk about all the logarithmic properties, remembering back to advanced algebra. All of these properties we're going to be using to expand them so that we can take the derivative eventually. So for now, the natural log of 1 is 0. If you have natural log of multiplication, you can turn it into addition. If you have an exponent, it comes out as multiplication in the front, and if you have natural log of division, you can change it to subtraction. So just simplifying these, since we have division, that turns into natural log of 10 minus the natural log of 9. That one's an easy one. On the next one, we have natural log of 3x plus 2 to the 1/2. And we can pull that 1/2 out to the front times the natural log of 3x plus 2. On C, we have the natural log of 6x minus the natural log of 5 because it was division. And then we can still simplify the 6x to natural log of 6 plus natural log of x minus natural log of 5. And D gets a little bit more complicated. First thing I'm going to do is just turn it into subtraction because we're dividing. Okay, so the next thing is we're going to pull that 2 down. And we have multiplication here, so we're going to turn it into addition. And we can turn that exponent on the second half into a constant out front as well, and then distribute our negative so we don't have any parentheses. And that's about as far as we can go. Okay, so now we're going to get into taking the derivative. The derivative of natural log of x is just 1 over x. That's just basic as it comes. But if we have a function, so natural log of u, which is a function, we put 1 over whatever that function is times the derivative of the inside. So it's kind of like the chain rule. So if we're taking the derivative of natural log of 2x, we do 1 over 2x times the derivative of 2x, which is 2. So 2 over 2x turns into 1 over x. That's that one. Second one, we have another function as well. We're going to do 1 over x squared plus 1 times 2x. So 2x over x squared plus 1. Third one, x natural log x. That is the product rule. So f times g prime plus f g prime. No, backwards. Plus g f prime. There we go. So this is x times 1 over x is just 1 plus natural log of x times 1 is just natural log x. That one's done. Part D, it looks like we have a chain rule question. Bring the 3 down, leave the inside alone, lower the exponent, times the derivative of the, lower the exponent, times the derivative of the inside, which is 1 over x. So 3 over x times natural log x squared. So we're going to use those logarithmic properties that we went over on the first page now in order to simplify the function first before we take the derivative. So the natural log of the square root of x plus 1 can turn into natural log x plus 1 to the 1/2, and that 1/2 can come out front. And then this isn't too bad to take the derivative of. 1/2 stays out front times 1 over x plus 1, and the derivative of the inside is just 1. So 1 over 2x plus 2, or 2 times x plus 1 on the bottom. That's when we have to simplify quite a bit before we can take the derivative of it. Natural log x plus 2 times the natural log of x squared plus 1 minus 1/2 natural log 2x cubed minus 1. Take the derivative of each one of those terms. Natural log x is 1 over x plus 2 times 1 over x squared plus 1 times 2x minus 1/2 times 1 over 2x cubed minus 1 times 6x squared. So let's simplify that a little bit. 1 over x plus 4x over x squared plus 1 minus 3x squared over 2x cubed minus 1. Okay, not too bad. Find the derivative of y equals x minus 2 squared over the square root of x squared plus 1. So this is called logarithmic differentiation. If there's really no pleasant way to take the derivative of this, one way that you can do it is taking the natural log of both sides. Okay, and then what we're going to have to do is do implicit differentiation and take the derivative of both sides. So if I take the derivative of the left side, well, before we do that, I think we should probably simplify that right term. So natural log of y equals 2 natural log of x minus 2 minus 1/2 natural log of x squared plus 1. Now let's take the derivative of both sides. Taking the derivative of natural log of y gives us 1 over y times dy dx. Take the derivative of the right side, 2 times 1 over x minus 2 minus 1/2 1 over x squared plus 1 times 2x. Simplify a little bit. Two over x minus 2 equals x, whoops, not equals, minus x over x squared plus 1. And now, remember, we're trying to solve for dy dx. That's the whole point of taking the derivative, is finding dy dx. And we have 1 over y over there, which is in our way. So I'm going to multiply the whole thing by y. And what is y? Well, we don't want to have two variables, so this is y. So our final answer for dy dx is 2 over x minus 2 minus x over x squared plus 1 times our original, which is x minus 2 squared over square root of x squared plus 1. That's it. Okay, this is telling us that if we have an absolute value, so if we're taking the derivative natural log of absolute value of u, it's the exact same thing. It's u prime over u. So you don't have to do anything different for an absolute value. So if I'm taking the derivative of natural log of absolute value of cosine, 1 over cosine times the derivative of cosine, which is negative sine. So it's negative sine x over cosine x, which is negative tangent x. Our last question is to find the relative extrema of this function. So what we're going to have to do is take the derivative. So here's our derivative, and I want to know when this derivative is equal to 0, because that's how we find extrema. And so dy dx is equal to 0 when x is negative 1. So we need to figure out if that's a min or a max. It's extrema, we know. So we're going to test from negative infinity to negative 1 and negative 1 to infinity. We're going to test values, and we're going to test it in the first derivative. Let's test 0, and let's test, whoops, can't do 0 there. Let's test 0 over here. Over here we'd have to test negative 2. What's going to happen is we are going to have negative and then positive, which means we have a min. at -1. We have to plug -1 back into the original to find out what the y value is, and the y value ends up being natural log of 2, and you can certainly leave it like that. Okay, and that was all we had for section 5.1 on taking the derivative of natural log functions.